10. WASP 76b. Observed in 2013, WASP 76b is gravitationally locked to its star. That is, it does not rotate around itself, and one side is always facing the star. As a result of this situation, the temperature on that side can reach 2,500 degrees. This is a heat that will melt iron. The other side of WASP 76b is constantly experiencing night. Iron, brought by winds to the night side at 1,500 degrees, cools and bombards the surface of the planet in liquid form. 9. Upsilon Andromeda b. It is another planet that is gravitationally locked to its star, and its year lasts about 5 Earth days. What makes this planet interesting is the radical difference between its sunny side and its night side. While the side of the planet facing the sun is 1,600 degrees, the night side is minus 20 degrees. Moving from one hemisphere of the planet to another is like jumping into an active volcano. The reason for the stark difference between the two sides is related to the fact that the star has an extra hot area at the exact point where Upsilon is looking. The planets we've mentioned so far might make you think that everywhere outside the solar system is filled with hellish temperatures. The main reason for this is that it is easier to detect planets closer to the star. However, there are a few exceptions. 8. GJ 504b. This beautiful pink or magenta-colored exoplanet is a member of the constellation Virgo. Gliese 504b orbits its star about 9 times farther than Jupiter is from the Sun. An interesting feature of this planet is that it is a newly formed planet, so it appears purple because it is still glowing with heat. 7. Ogle 2005, Bleg 390 lb. More than 20,000 light-years away in the constellation of Sagittarius, a red dwarf star shines faintly against the darkness of space. Red dwarfs are some of the smallest and coolest stars in the universe. Ogle, orbiting one of these dwarfs, is one of the coldest known planets in the universe. The surface cold of minus 220 degrees Celsius covers the entire planet with glaciers, ice canyons, and giant icebergs. The possibility of hot magma at the center of the planet increases the possibility of living beings. 6. TRES 4b. Located 1,400 light-years away. In the constellation Hercules, TRES 4b is one of the largest exoplanets ever discovered, alongside WASP 17b, WASP 12b, Connecticut Chameleontis b, and GQ Lupi b. Although it is more than 1.7 times the size of Jupiter, it has a very low density. Scientists often compare the density of TRES to a bottle cork. 5. Kepler 78b. Kepler 78b is similar to Earth. This exoplanet is located in the constellation Cygnus. The strangest part is that it is located only 885,139 kilometers away from its star. Its star is 40 times closer to the Sun than Mercury is to the Sun, and its temperature is estimated to be around 2,030 degrees Celsius. According to Francesco Pepe, who has conducted research on the planet, Kepler 78b may be the size of Earth, but it can be thought of as a lava planet rather than an Earth-like planet. 4. Ogle 2000, 16 BLG, 1928. Scientists believe that the Milky Way is filled with dozens of cosmic orphans, and Ogle is one of them, a planet that was formed in the star system by conventional means and broke away from the system after it could not get along with the gravitational force of its star and the planets around it. He's still going somewhere. He hasn't stopped coming back, but it's not clear where he's going. If the stars are aligned correctly, it may enter another system or hit a planet somewhere. We don't know. 3. Kepler 10b. Kepler 10b orbits its star 1/20th as close as Mercury. It has years shorter than an Earth day and has a surface temperature of 1,300 degrees. The planet's surface is covered in lava, much hotter than on Earth, and radiation from its star is melting the iron on the planet. The fact that it has no atmosphere, as a result of being close to its star, allows iron to leave the planet and form a tail around it. Its lava-filled surface reminds us of the planet Mustafar in Star Wars, the planet where the deadly duel of Obi-Wan Kenobi and Anakin Skywalker took place. There are certainly planets more ideal for a duel. 2. Gliese 1132b. Gliese 1132b and Earth are similar in many ways. They have slightly more mass than us. Their age is 4.5 billion years, and we are almost the same. The biggest difference is that it follows its red dwarf star much more closely than us. The Earth's rotation, completed in 1.6 days, also causes a surface temperature of 137 degrees. Additionally, incredible amounts of radiation have wiped out the planet's atmosphere. The interesting part is that the star's gravity creates incredible tides on the planet. As the planet is squeezed and released by its star, volcanic activities occur at great speed, and the gases in the interior rise to the surface. Gases on the surface are used to establish a second atmosphere for the planet. NASA noted that the re-established atmosphere is a phenomenon in itself. Another opportunity that the second atmosphere offers observers is the chance to study the planet's internal chemicals. 1. Planet, black hole planets. The most interesting planets are not formed by conventional methods. The existence of planets formed by the gravitational pull of black holes rather than a star or seems increasingly likely. The extremely dense areas around massive black holes are ideal environments for planet formation. For now, we have not discovered a planet that has formed around a black hole, but we have ideas about the planets that will emerge. The existence of a black hole planet is possible in a very small area. These are areas close enough to receive radiation from the center of the black hole, but far enough not to be drawn into it. So if a black hole planet were to form, its 1-year orbit would be equal to millions of Earth years. Since the radiation from the center of the black hole will continue continuously during the formation of the planet, these planets will be much larger than the ones we know. On the other hand, since it will have different elements from the elements that an ordinary star provides to its planets, this means that we cannot classify these planets as rocky like Earth or gaseous like Jupiter, and we will need new terms. Even the closest black hole is outside the observation limit of the tools we use for planet detection, meaning we cannot yet observe these possible planets. New technologies that will develop in the coming years may enable us to make definitive judgments about black hole planets. I hope you liked the video. We will continue to find the wonderful planets of our universe. If you want more videos like this, I would appreciate it if you subscribe to the channel and like the video. See you in the next video.